young math Padawans, it's Mrs. Angel with your lesson for today on the order of simplifying. Now, this is also known as the order of operations. Maybe you've heard it as PEMDAS or GEMDAS or GEMS. However you've heard it, today we're going to take all of that and simplify it into two simple steps. Step 1, identify the terms in the expression, and then step 2, simplify the terms. From there, you just combine from left to right, and it's easy as that. So grab these notes and let's get started. Before we can begin, we need to talk about some terminology. Expressions are made up of what we call terms. Terms in an expression are separated by addition and subtraction outside of parentheses. So as long as you can identify the terms in an expression, you can simplify each term individually, and then you're just combining integers at the end. So there's 4 different examples of terms that we're going to be looking at in this video and in our practice. The first type of term that we're going to look at is what's called a group. Now for this class, a group in this case will just be consistent of whatever is inside of parentheses. Now inside of parentheses you could see a sum or you could see a difference. But what's really telling you that this is a group are those parenthesis symbols. These grouping symbols around the sum and the difference, and whatever's inside makes up that term. Second type of term that we won't really be talking about a lot in this class or in this video is called a power. And we've seen these as our base, something raised to the exponent of something else, or sometimes you'll see a negative power raised to an exponent, etc. Powers are another type of term. Third type of term that we're going to look at a lot in this class are products. To represent our products, you've seen many different ways. You started off seeing the X symbol, then we introduced the dot symbol, but in this video, we're going to be looking at products also using parentheses. And the way that we can tell this is a product and not a group is because one of the factors is outside of the parentheses and one of the factors is inside. So we would read this as A times B. But you can also have a product with a group, something like A times the group of B plus C. And that's another type of term, again, because of those parentheses. So this type of term is called a product, which basically means multiplication. And the final term that we will see is the quotient. And normally we see this symbol to represent quotients, but not in this class, not in this unit. In this unit, we will be looking at fraction bars to represent quotients that we would read this as A divided by B. Or you could see a group in the numerator and in the denominator. A plus B divided by C minus D. That's another type of term. So as I mentioned in the intro, the order of simplifying is pretty simple. Step 1, find all the terms and do that math first. So we're looking for groups, anything inside of parentheses, sums or difference. We're looking for any powers. We're looking for any products and any quotients. And we're making sure that we do all of the math in that single term first. And then it's as simple as go in and combine everything that's left from left to right. So let's get into today's examples. So number 1, we would read this as 5 times the group of -1 plus 6. Now, terms are separated by addition and subtraction outside of parentheses. Well, this addition sign is inside of parentheses, so this is actually one term. It's just a product of an integer and a group. So we go through our simplifying steps. The first thing we're going to do is simplify what is inside of that group. We're going to do that operation first. And we're going to make sure to keep the structure of this expression as we go. So what is -1 plus 6? That would just be 5. And that 5 that was part of the original expression is still there. So instead of 5 times the group of -1 plus 6, now it's 5 times 5, which is equivalent. And this is a product, so to simplify that product, we just do the math. 5 times 5 is 25. And once you do all the math, we call this the value of the expression. In other words, all the math is done. Take a look at example number 2 here. Aha! This time I do see an addition sign outside of parentheses, which means that it's separating two terms from one another. So we're going to multiply 5 times -1, which is -5, and bring down the rest of our expression. Now that both are simplified integers, we can just do this math and simplify this sum. -5 plus 6 is +1, and you might need a number line for that math if you weren't sure. Last one, 5 minus 1 times 6. Now be careful here. The most common mistake that students make is just reading this as 5 minus 1. But it's not 5 minus 1. It's 5 minus 1 times 6, which means if we look at this carefully, this is subtraction that is separating two terms, 5 and this product. That second term is unsimplified. So we're not taking away 1 from 5. We're taking away 1 times 6 from 5. So we're going to simplify that product first. 1 times 6 is 6. So we're actually taking away 6 from 5. 5 minus 6 is -1. So even though all three of these expressions had the same digits and similar operations, they were all simplified very differently and have different values. On to our next 3 examples. Again, all containing similar digits, but different expressions altogether. Let's look at example 1. Example 1, I see that there is an addition sign outside of parentheses that separates 2 from 10 times 2. So this is not 2 plus 10. This is 2 plus 10 times 2. So we have to do that math first. 10 times 2 is a product, 20, and that's what I'm adding on to 2. 2 plus 20, that's simple math. This expression has a value of 22. What's different about expression 2? Here we still have addition, and the first term is still 2, but the second term is now called a quotient. A quotient means it contains division. So before we can simplify this expression and combine it with 2, we have to simplify this quotient. 10 divided by 2 is 5. Bring down your sum, and now that everything else is simplified, we can now add on that 5 to the 2. 2 plus 5 is 7. What about this last one over here? What do you see in this example that you didn't see in either of these? If you said a group, you were correct. This whole expression is actually a product. It's 2 times 10 plus 2, but before we can multiply, we need to simplify 10 plus 2. So let's do that. 10 plus 2 is 12, and now we can bring down the rest of our product. And 2 times 12 is 24. Again, 3 completely different expressions, which means there should be 3 unique values. These next 3 are a little tough, but I think you're ready. So go ahead and try these expressions on your own now. How did you do? Did you end up with -10, -10, and 14? If so, well done. If not, let's see where you went wrong. For our first expression, we have 12 minus 2 times 3 minus 4. This is a product of 2 groups. So the first thing I did was identify where those 2 groups were. Notice that the 12 minus 2 is inside of parentheses, which means that's math that I'm going to have to do first. So I set up my structure here to show that it's going to remain a product. Notice that there's no addition or subtraction between those parentheses. I'm not adding these groups together. I'm not subtracting them. I'm multiplying them. So 12 minus 2 is 10, and 3 minus 4 is -1, which when multiplied together gives me -10. In our second expression here, this is a quotient, but the numerator and denominator are both unsimplified. So I need to simplify those before I can divide. Again, 12 minus 2 is 10, 3 minus 4 is -1, and 10 divided by -1 gives us -10 again. Interesting, both of these expressions gave us -10, which means these are what we would call equivalent expressions. They have the same value. Now this one was a little tougher because a lot of you probably also got -10 here, because many of you, I'm going to guess, did that math first, that 12 minus 2. But hold on, there's no parentheses here to show that that math should be done first. In fact, this is not 12 minus 2, it's 12 minus 2 times 3 minus 4. This entire thing, this product must be simplified before you can subtract it from 12. So I identified that there was subtraction here separating the two terms, and there was also a group in that second term that needed to be simplified. So I simplified the group 2 times negative 1 now, but you still don't separate, you still don't do 12 minus 2 next because there's no parentheses there. The next step would be to simplify the product, negative 2. So 12 minus negative 2, I knew that that was equivalent to 12 plus 2, and 12 plus 2 is 14. So it's important not to put in any parentheses unless you see them originally. So on to our last 3 examples here. Go ahead and try these now. Careful to keep in mind where your terms are and where your parentheses are. How did you do? Did you end up with negative 15, 6, and 31? If so, great job. If not, let's see where you went wrong. In our first one here, we do have a sum of 2 terms, that addition sign's outside of parentheses, and we also had a group, 5 minus 8, negative 3. Now we have a product to simplify. That makes us negative 18. Negative 18 plus 3 is negative 15. In our second expression, this is just a difference of 2 products. So I've simplified them both at the same time. 6 times 5 is 30, 8 times 3, 24, and 30 minus 24 is 6. Our last one again, there's no parentheses around that 6 plus 5, which means we are not doing that math first. This is 6 plus 5 times the group of 8 minus 3. 8 minus 3 is 5. 5 times 5 is 25. When added together, we have 31. So just remember, simplifying should be simple. Find all those groups separated by addition and subtraction around or outside of parentheses, and once you simplify them, you're just going to be left with integers to go from left to right. That's it for today's lesson. I will see you next time.